Yeah, thanks everybody. So to introduce myself, my name is Scott Coull. I'm the director of the data science research team at Mandiant. I've been working in data-driven research, security research for about 20 years now, if you could believe that. I published my first paper in 2003. It really like ages you when you think about those things. Pass it over to John and then I'll...
Yeah, John Whitcomb. I have worked in security operations centers, both in a consulting capacity and also working at the client site, building them over the years. So a lot of security operations experience, and currently I support the automated defense product at Mandiant.
And I'm Ben Withnell. Most people at Mandiant call me Bubbles, so when you inevitably hear these guys use that name, they're talking about me. I've been at Mandiant for about 10 years, started in our Managed Defense Security Operations Center, and these days I work on our intelligence team, working on how we use our intelligence to detect intrusions and all that fun.
Yeah, so you're probably thinking like, wow, this is a really weird group of people to get up on stage all together to like talk about, you know, ML and data science and then also the human aspect. But I guess that's actually the whole point of this presentation, right, is actually to share some of the experiences that we've had in building some stuff at Mandiant, partnering together across organizations, everything from security architects, threat intel, data science, finding a way, and hopefully you'll get this theme, to not just slap ML onto human processes or slap humans into ML processes, but to really work to find ways to weave these things together very nicely so that they kind of work out sort of the best of both worlds, so to speak. So I'll start off by just telling you guys a story, right? I'm sure this is a story you've all heard, probably heard it like 10 years ago. There once was a security analyst, a SOC analyst. They had too many alerts. They were drowning in alerts, in fact. And the question became, well, okay, how can we make their life better? How can we give them more time to focus on the alerts that are important? How can we give them better visibility, et cetera, et cetera? And for a while there, at least from our perspective, the view was, well, if we give them machine learning, we give them data analysis tools, we give them things that will help them provide them with sort of this automated contextualization, it will magically fix all their problems. And I think what we've come to find out here is that, in fact, that's not true. In fact, in some cases, the exact opposite has happened, right? If you look at alert volumes today versus 10 years ago, it's massively worse in some ways, due in part to the fact that we now have so much machine learning and automation in the detection side of things.
Yeah, and I experienced this firsthand working in security operations centers, saw tools, UEBA type tools deployed right next to a SIEM, except the SIEM was still running, still looking at the old alerts, and then the UEBA was identifying these statistical anomalies. And so that was interesting, and on occasion, those UEBA tools have proved to be valuable. However, a lot of times there's a lot of false positives, a lot of processes where, for example, your UEBA tool identifies when your company processes payroll. I've seen that a bunch of times with UEBA tools because that's an anomaly. You're not usually processing payroll. So that type of thing we'd see create a lot of noise and a lot of extra work for security analysts where the expectation was it was going to be reducing that work. The other flavor of machine learning that we've seen is sort of the bolt-ons to existing products where you see we have an IDS sensor, now we've got an IDS sensor with ML built in. And that also proved useful from time to time. However, in a lot of cases, the context behind that ML rule that fired is lost to the analyst. So as an analyst, you look at that alert and you see some anomalous network thing happened, but I don't understand what, and this rule didn't really explain it to me, so I can't actually use it. So those are kind of the two types of ML that, like in the field, security analysts and operators have experienced, and it hasn't truly kind of delivered that value. So this talk is about a better way.
Yep, and that brings us to this next slide here, right? So kind of the theme for this talk, right, is, again, like I was saying, how do we weave those things together, right? So on the one hand, we have all this great human expertise. On the other hand, we've got a ton of data that literally is impossible for any human to go through in their lifetime. So what do you do here, right? Do you take this approach where you kind of think about, you know, the machine tossing something over the fence to the analyst, or the analyst tossing something over the fence to the data science, you know, people in the machine learning teams? Or is there a better way where you can actually kind of coexist together, involve everybody in the development process, and actually kind of work towards, what you will see here is a kind of a design pattern that we've used to help kind of figure out whose role is in each part of this, and then also how we can interact and kind of help each other. So let's sort of set the stage here a little bit and just kind of make this explicit, right? So on the human side, we've got a ton of complex, semantically rich knowledge, right? The idea of understanding the technology that's actually underlying this data, understanding the threats that are underlying the alerts and the data that they're seeing. They also have the ability to kind of make these leaps between sort of otherwise disconnected points, right? They might see two things happen at completely different times, maybe even on two completely different host systems, and all of a sudden in their mind, it clicks. Oh, that's what is happening here. And it's not in the data necessarily, it's not necessarily directly observable, but it's something in their knowledge and expertise that has helped them find this missing piece or missing component. But the sort of con here is obvious, right? They just simply cannot scale. You cannot have a complete army of security analysts out there with this amount of knowledge and this amount of specialization to be able to really get all the way through all of the possible alerts and threats that your organization faces. To flip that, right, let's talk about machines here for a second. Obviously the scales, right? That's the whole point of the sort of automation machine learning concept. But at the same time, is also kind of really helpful in being able to identify complex patterns, right? Human brain can only pack so much information into it at one time. Even if it's super rich in terms of its understanding of the data, there's only so many data points that a human brain can really understand and kind of think through at one time. At the same time, it also kind of gives an opportunity to challenge biases, right? So like certain analysts go into different situations, and they immediately, based on their prior experience, have a predisposition for certain things that might not be actually held up by data, but because of their gut instinct, they might go forward with it. And this, again, provides a way of kind of checking that in some ways. But then the con here is, again, it's basically the contrapositive here, the opposite of the human side, which is it's a shallow understanding, right? The machine learning models can only understand as much as we can feed them with data. Data in itself is very limited in what kind of observations it can encode. There's all sorts of other issues that go into that. So what we'll be doing here in this talk, and this is just sort of an overview to kind of give you an idea of what we'll be talking through. So we'll be presenting a scoring framework here. And the idea was that we had as a group here up on the stage had been kind of asked a number of different times to score different things, right? Score vulnerabilities, score indicators, score alerts. And we found ourselves talking in sort of similar ways about all these different problem spaces, right? And so we've kind of come to what I would call a sort of a design pattern, but basically you can think about it as a framework, whatever word you want to use there. And so we'll be going through that step by step here. Just to focus the discussion a little bit and to make it a little bit more concrete, we're going to be talking about this specifically in the sort of case study of indicator-based alert triage. So what that means is, you have a whole bunch of indicators of compromise that you've gotten from different threat sources. You have all your alerts. You're basically trying to marry up indicators with alerts that you found or other events that you see in your system and trying to triage, well, which one of these events that had indicator hits are really things that we should be bothering to look at. So we're going to be talking about that specific use case first. We'll talk at the very end of this about other potential ways in which we could use this. Certainly always happy to answer questions too at that stage. We'll be breaking this down actually into 3 different components. And this is sort of the design pattern piece here. So the first thing I'll start with, and I'm probably somewhat preaching to the choir here on some of this stuff, but it's kind of our belief that you can't really have a single score that's just going to magically capture everything that every organization and every role in every organization will want to get out of this particular type of scoring, right? So let's say indicators. You have threat intelligence analysts, you have SOC analysts, you have threat hunters. They might all want to use indicators in different ways. So one score is never going to meet all of those use cases necessarily. So what we did here is we kind of break this down into 3 components. So the first one, first step here you can kind of think of is confidence, right? is this thing actually malicious or not? Now, for those who work in sort of the threat intelligence space, you'll know that threat intelligence feeds are notoriously noisy in terms of what they bring in. There's also all sorts of other kind of interesting things that happen in the background, right? So you might get 3 different feeds coming in, but they're all coming from the exact same source. So they end up being highly correlated with each other, right? So just doing simple statistics on them are not necessarily going to be, give you good information. So the first thing we need to do here is go through and determine if something is actually malicious. Once we do that, once we can kind of separate the wheat from the chaff, so to speak, we can go on to severity. And that's the point at which we can really leverage some of the human expertise and understand more about like, well, all right, in a general sense, is this actually a high impact threat or not for the customer? And the final aspect here, which we're really just starting to really dig our teeth into, is this customization aspect, which is, okay, well, we can provide you with a general sense of, okay, well, spam is not so severe, and well, a threat actor group is severe. But what happens if you, as an organization, care a whole lot about a very specific type of threat actor or a very specific type of malware that you see out there? How do you customize that severity rating so that you're not just giving them kind of this generic blanket statement on here's what we think you should be doing, but instead can actually customize that to their needs? And so the way to think about this, right, and again, I've kind of said this theme a couple times, this sort of weaving human and machine competencies together. The way I kind of think about this, the stuff that we're talking about here is, you can think about it in one camp as sort of machine-led. So that means like the machine's doing a lot of the heavy lifting in terms of like putting all the pieces together, giving the actual result out. Followed by human supported, which means that machine might use some of that human intelligence, some other human curation in the background as information to operate on. And you can kind of compare that or juxtapose that to the sort of human-led but machine-assisted case, right? And sort of the opposite of that. And so in each of these things, right, so for confidence, we're going to be looking at a machine-led case where we're looking at data-driven assessment that uses both human and machine-driven or human and machine-derived information to assess quality. For severity, we're looking at a more human-led effort because, again, that's going to leverage all that expertise that they have. And then on the customization side, we have a really nice and interesting blend here, right? Because the machine learning aspect gives some really great recommendations, but it's actually really important to couch those recommendations in things that are realistic and actually make sense with respect to sort of the threat landscape. And Bubbles will talk more about that at the end. So all right, let's get started into some of these things now that we've kind of gone through all the intro material. So confidence, do we believe this is actually malicious? So I'll start out here by just kind of talking through, at a high level, like, all right, what does an analyst do when they get a new indicator in, right? We'll just say there's just one indicator for now. We know, in fact, that there are millions of indicators that sometimes they get over the course of weeks or months. So they have one indicator. They want to know, all right, is this thing actually something that's worth my investigative time to go and look up, go investigate, go look into the alerts and other things? So what they're going to do is they're going to use their SOAR platform. They're going to, if they're in kind of an unlucky situation, they're going to go hit this with a bunch of Python scripts or even do this manually, right? Go virus total or different types of sources and look up these indicators, right? So they might go to their intel reports, right? Their highly curated human intel reports they have access to. They might go to threat intel feeds, which are known to be noisier. They might go through old alerts that they've already dispositioned in some way. And you can kind of go down this list and think about like, all right, here's all the different enrichments that they're getting. You can even think about some of the ML that might be an enrichment in this case, right? They might have a DGA detector, might have some other type of interesting predictive ML or scoring that's happening that in and of itself is not something that they care about enough to kind of be a strong signal, you can say, right? So these are all, you almost think about them as weak signals. There's almost nothing in here that's like, as soon as it goes off, you ring the alarm bell and you spend all your time on it. You instead, as an analyst, look at all these sources, assess how you feel about them effectively, right? Like, what has your past experience been in using these sources? How much confidence do you have? How much weight do you put behind them? And then you kind of, in your mind, put them all in there, mix them around, and then you make a decision. Well, okay, given all the information I have about this, given the weight I have about this, each of those information sources, it's either malicious or benign, right? I make a decision. Well, the downsides of this are probably pretty obvious, but it's super repetitive, right? Like analysts that have to like constantly be going to VT and all these other sources to get enrichments, like it's like a monotonous thing that you have to end up doing. It's also very time consuming, right? This is actually a step that if you don't have necessarily a really well-developed SOAR platform, is actually a really time consuming step to go through and then actually to kind of look at and assess what information has come back. And then of course it's difficult to scale because it's human, but then I think there's another interesting aspect here, which is the high variance component. You know, I said earlier on that sort of these pieces of information go inside of an analyst's head and get mixed around and then a decision comes out. Well, each analyst has their own preconceived notions of, you know, here's the value I see in this versus the value I see in this other piece of enrichment. And so it's oftentimes the case that you will even have high variance across different analysts in a single SOC, depending on how those analysts are trained. So what we did here in this particular case for indicators is we actually took advantage of a system or an approach in machine learning called weak supervision. The general idea here, and I'm not going to do any of the hand-wavy math stuff, but the general idea, right, is that instead of requiring each of these analysts to provide like very strong labels, this is definitely a good indicator, this is definitely a bad indicator, we instead look at this problem the same way the analysts do. We say, okay, well, we know that there's a whole bunch of weak signals in here for us to take advantage of. None of them are strong enough on their own for us to kind of make any decisions on, but we can kind of turn them into like neat little functions, right? You can even think about doing this for Yara rules, right? If you had some loose Yara rules out there, you throw some Yara rules into these functions, and you say, all right, well, if you have a Yara hit, if you have certain types of enrichments come back on an indicator, those are all positive signs that are like, maybe that's a little bit more malicious, a little bit more interesting for us to look at. Same thing goes if you have like a machine learning model that can say, no, this is definitely benign, or I think it's benign. You can weight it accordingly and take it into account. So after you can kind of think about kind of taking the analyst's thought process, building it into these labeling functions, and then you can actually have the analysts themselves provide some initial weights, right? So this is, for those that are interested in kind of the math side, it's like a Bayesian prior, right? The idea that what's your prior expectation that a given source here, a given enrichment is actually giving you the correct information, right? It's actually a true positive, so to speak. And what will happen here is we're actually going to take that initial weight and use that as our starting point in the machine learning process that then allows us to take millions and millions and millions of indicators that we've accumulated over time and then bounce those assessments against those indicators, at the same time taking care to make sure that we're that we're addressing the correlation issues that might be happening underneath the hood across all these different threat feeds, and come up with basically an adjustment to those weights, right? Oh, well, this analyst thought, in fact, that this DGA detector should be weighted very low, but actually we found that in our data, it actually correlates very well with actual problems or actual bad indicators that are out there. So we should maybe boost it up higher than what that analyst or set of analysts came up with initially. And then finally, you can kind of think about this as like a weighted vote, right? Kind of a simple concept. You have a whole bunch of information that comes in. Not necessarily all of these things are going to give you information every time, so there'll be some abstains from that voting. You can weight those votes based on that confidence level that you've kind of assessed both from the analyst side of things and from the data-driven side of things. And you come up with a final answer here, right? Based on everything I've seen, I think it's 98% probability of being malicious. So what I really want to stop here for a second is just to like harp on this human-machine feedback loop just a little bit before I pass it on to John, which is, we have this really neat process that we've ended up kind of falling into almost, where the analyst can create and kind of take their knowledge, put it into these labeling functions, create these noisy features, and then basically imbue the process with their new detection logic, right? Almost at each iteration, without any knowledge from like, hey, how much ML do I need to know to do this? It's literally like a Python function. And then they can weight those things based on what their kind of prior beliefs are, send it into our machine learning process, which then takes an absolute ton of data to come in and make the adjustments and make sure that those weights are correct and adjust them accordingly, and then go all the way back around to do validation and do updates, right? So we get to go back to the analyst, we get to give them another opportunity to both kind of validate that the machine learning process worked well, but also to kind of check their own biases. So they'll be able to see, for instance, that like, hey, that one enrichment source that I thought was really, really good, for some reason, the number here that the machine learning model is giving is very low. I'm gonna go check into why that's the case, and to kind of check their own biases that way too. So it's a really neat kind of process that we fell into. So just to kind of highlight here, to end up my section, on the human side, we're taking advantage of all of their experience, all their expertise, right? They're able to develop these really nice kind of Pythonic functions and rule-based functions, as well as other kind of enrichments that we could use to do this type of confidence scoring. They provide us with the initial weights, and then they do the reviews at the end. Meanwhile, on the machine side, we're doing this data-driven adjustment using huge amounts of indicators that a human would never be able to look at, and then automatically handling all of that sort of underlying hidden correlation that a lot of humans don't really fully understand even exists in some of this data. And of course, we have this nice mathematical framework to kind of speak about what exactly it is that we're talking about when we're talking about this scoring. So with that, I'll stop there and I'll hand it over to John.
Thanks, Scott. So next, I'm going to talk to you guys about scoring severity. So once we have a confidence, what Scott just talked through, that's kind of actually just the beginning, not the end. So we know that we may be highly confident that an indicator is malicious, but not all indicators are alike. And so being highly confident that something, for example, is an outbound call from inside your environment to malicious infrastructure that's used for exfiltration is way, way different than, for example, if a threat actor scanned your internet perimeter. They're probably doing that every day. You may not even care about that. And so once you understand that, and once you have some confidence that an indicator is malicious, you need to start figuring out kind of what is the severity, and that's kind of what I'm going to talk about next. So when we're scoring severity, what we basically did was, all right, let's just take those things that we were at least 80% confident in and push those through and kind of drop out the rest. Now that isn't to say that those things that we had lower confidence about aren't interesting at all, but the likelihood that they are interesting and worth your time is low enough that we felt comfortable dropping that out of the sort of result set. And so then we kept things, and then we needed to kind of figure out what those different functions were that we'd look at that are more situational in nature to understand, is this something that I would care about as an analyst in a customer environment? And so we look at those additional context enrichments, and we essentially did a down selection, up selection process. And so I want to get into that with you a little bit in this next slide. So here's some factors that we used in this use case to do that down selection. So we basically took the kind of questions that an analyst might ask, and these are just a few examples. This isn't the whole model, but just an example of a few of those things, that when you're an analyst and when you are presented with a threat intel hit, what are the questions that you ask? One of the top questions is this some kind of shared internet infrastructure? Because yes, maybe an adversary used that internet infrastructure, but it doesn't mean they always use it. It doesn't mean every hit against that specific IP address is necessarily malicious. And so understanding, is this shared infrastructure, or is this really like a dedicated IP, dedicated domain name, et cetera, that's only ever malicious, is a huge factor that we wanted to consider. Then looking at other things like dynamic cloud hosting or Tor. Now, it might be interesting. A lot of times, Tor traffic is interesting, but it isn't really the IP address in that situation that makes it interesting so much as it's somebody using Tor. That's actually the interesting component. It's not necessarily tied to the actual threat intel hit because it's just the nature of the way Tor works. Also, is this associated with like adware or something that is generally seen as nuisance sort of malware, or is it something that is more targeted? And if we identify it as something that's sort of more nuisance and less adversary, then we down select on those functions. And then this next page is really about what we up selected. So there are things that if you do know or are answered kind of as a yes or in the affirmative, that I probably care about that a lot more. One of the critical factors that we considered here was there an active breach that Mandiant worked in an incident response engagement in the past 90 days that saw that indicator? That type of indicator, we believe, is some of the most high fidelity indicators that we can provide to our customers. And so we wanted to highlight that really boldly for our clients. And that is to say, not only has this indicator been used in a campaign, but it's been used in a breach response that we identified and is somehow associated with that breach. That's just way more compelling for our customers. Other things we look at is kind of, is this commodity malware? Is this something that all of us have had to deal with in our SOCs? Every week you get kind of a new malware embedded email campaign, and you got to kind of deal with that. Now that's interesting, and SOCs usually still have to do some amount of response there to make sure that gets managed. But generally that's not nearly as interesting as if you have an Iranian-based threat actor group targeting your web infrastructure or something of that nature. So just a difference there in terms of up selection, down selection. Next up is do we have an APT attribution? So Mandiant collects a lot of intel. We're constantly processing millions of indicators, and we are constantly researching those things. And so sometimes we'll have an indicator and we'll know that it's associated with some sort of malicious activity, but we may still be researching it. We want to let our clients know, hey, we saw this in something, but we may not have figured out that attribution yet on that indicator. And so if we don't know that much about the indicator, it could be more malicious or less malicious, but we just don't know enough to really have high confidence to prioritize that for our customers. Whereas if something's clearly attributed to an APT group, that's something that typically an analyst is going to say, okay, I know this is Iranians. They conduct web exploitation campaigns or website defacement campaigns. Oh, and this touched a web server. All of a sudden, I really, really care about that. So that type of factor is what we considered in sort of the up selection of that severity scoring. So again, just an overview to talk about kind of what we talked about here in terms of severity. So we're really taking these things, we're combining the human input with the machine to process. We ask the questions that a human analyst would ask. We ask those questions with our ML and scale it out because it can be very boring, repetitive work. If you've ever worked in a SOC or responded to threat intel hits, you know how boring and frustrating that can be. But the questions that we ask, the thought process we go through is where the value is added. So how do we work with the machine, in tandem with the machine, to get the answers that we need instead of just, again, receiving something from over the wall? And so with that, I'll move on, hand it off to Ben.
Thanks, John. So customization is the fun part for me because I'm an Intel nerd, and this is where we can start doing Intel-y things. But it's also fun within our human and machine framework because the confidence stuff that Scott talked about is machine-led with humans in that loop, and the severity piece that John just talked about is human-led, where the humans are defining those bins we're categorizing everything into, and the machines are just implementing that. Customization starts becoming a really more nuanced blend between the two, which becomes just a fun problem to start working through. But in general, for customization, our whole thought is we can filter out indicators that we are not confident are malicious. We can further prioritize indicators based on generic threat context, but that's not going to be enough. The analogy I like to use is like the Billboard Top 100 music lists versus Spotify's curated playlists, or dating myself a little bit, the most rented movies at Blockbuster versus Netflix's customizations. There is value in generic severity, knowing that in general we would prioritize a hit using the severity logic that John walked through is helpful, but it doesn't go far enough, right? We need to tailor the ultimate prioritization to different organizations' risk tolerances and different components of the threat landscape, right? A financial institute might care about every single piece of malware that exists anywhere on their network, but a university might not, right? They might not care what happens on their dorm networks or their guest Wi-Fi or whatever. So how do we not just offer the generic, like, well, it's malware, so therefore it's important to everybody, and go to the university and say, well, it's malware and contextually it's in a place you care about, or it's not your average malware and it's more important, it's related to a targeted threat or ransomware or something like that, and tailor it to different risk tolerances. And the way that we have started looking at this, Scott mentioned at the beginning, this is kind of our next emerging area, but the way we started looking at this is building profiles, right? As an intelligence org, we build profiles for all types of threats. We can tell you for all of the threat groups that we track, the industries they target, the regions that they target, the malware they use, when they were last active. That again becomes important, right? John talked about prioritizing things that are attributed. Well, maybe you're an organization who cares about every single attributed indicator in your environment, or maybe you're an organization who only has time to look at ones that are likely to still be active because the threat actor was active yesterday. We can use information like that. We can gather the same types of things for malware, right? John talked about generically prioritizing based on, is this a malware family that is broadly used? Is it a malware family that's only used by 1 or 2 threat groups? We can use prevalence information and allow for customization and tuning. Because again, maybe you're an overworked SOC and you're like, I only care if this is new and novel in my network, otherwise I don't have time to look at it. Or you're well-resourced and you're like, yeah, it's malware, I want to look at it. We can marry those threat profiles up with an organization profile, right? What industries does the organization operate in? What regions do they operate in? What kind of software do they have in their network? Again, another piece of tailoring is like, we may say generically that AP241 is the most severe threat today because they're actively exploiting Exchange servers. If you're a Gmail shop, they're not that severe for you. How do we use that knowledge about an organization and better tailor it? And the way that we want to start doing this is building a recommendation algorithm, but this is where it becomes a blend, right? We want to allow the machines to identify those overlaps and those connections between our threat profiles and our organization profiles, but we can't allow the machines to do that on their own because, especially in the attribution space, everything gets really messy really quickly, and you can't allow a machine who is drawing fairly basic inferences from these data sets to come up with complex and like nuanced relationships here. We can let the machines promote to our analysts, like, here are the types of relationships I'm seeing, but we need our analysts to actually go through and validate, like, yes, that relationship makes sense, no, this relationship doesn't make sense. For any of you who have tracked the like ransomware ecosystem, you might imagine trying to let a computer just figure out, you know, what initial access broker is friends with what ransomware operator today isn't really going to work because it is literally human relationships, and so you need a human to understand that. And that's the general approach that we're taking, right? We can rely on machine learning algorithms to identify those relationships, but before they go anywhere, we need our humans to validate and codify those and say, like, yes, this relationship will always make sense, or this relationship is interesting, but it only makes sense sometimes, so I need to look at it and kind of approve that relationship so that we do this correctly, right? Because what we ultimately want to be able to do is say, let's take those rankings, let's take this output and customize our application of confidence and severity from before, right? John mentioned that in general, we say we have to be 80% confident that the thing is malicious before we even try and assign a generic severity to it. With customization, we want to be able to say, well, actually, you're an organization who cares deeply about ransomware, and we're only 60% confident that this indicator is malicious, but it's associated with ransomware, so you might want to spend the time doing it. We're ultimately asking an organization to spend more time investigating things that we have lower confidence in, and if we do that wrong, it obviously gets back to the original problem that we started at the beginning. We're making more work for people, which is why we want to have our humans in the loop here, providing a lot of this validation. But we do think that it can work and will work and provide a lot of value because, again, every organization is different. Even every persona within an organization is different, and tailoring the outputs coming from these machines to an individual, you know, SOC analyst or IR consultant or Intel analyst or whoever, and also tailoring it to different organizations will make folks even more efficient and allow them to more quickly respond to the threats that actually matter to them. And yeah, again, the humans are going to be the ones validating the relationships the machine identifies, but they're also going to be the ones creating the threat intelligence in the first place. I would love to be able to stand up here and tell you that we have fully automated threat attribution and tracking of threat groups. If anyone ever tells you that, they are lying to you. It is impossible. So we have our humans doing all of the data input, And the machines are just the ones, we're taking advantage of what they're good at, spotting relationships in data that an analyst may be biased against or, just not see because every analyst is always overworked. So let the machine draw those out. But to put it all together, hopefully you saw two parallel but related tracks throughout all of this. One is we can derive this more complicated scoring framework, combining confidence, severity, and some customization logic to more accurately prioritize indicators and alerts on indicators for SOC analysts, just in general. We also think that you can use that for other use cases, like Scott mentioned at the beginning, prioritizing vulnerabilities, prioritizing alerts that don't have any threat intel indicators in them, prioritizing assets even. But starting with the indicators. But we also hope you saw the value in weaving together the machine learning models with the humans and talking about that more clearly, right? Every machine learning model that's ever been created has a human somewhere in the loop because computers haven't become sentient yet. But we think you can do more. Hopefully you saw that there are more places to interject humans throughout these processes, and just calling attention to the fact that there are still humans in the loop and that the machines aren't coming to solve all of our problems, and we still have to work hand in hand together to solve these problems. Hopefully is a new lens to look at ML and security in general, but also this indicator problem in particular. And with that, I believe we have time for questions if anyone has any.
Yes, we'll stand up.
I think there's a mic. All right.
Does alert customization, or the customization part
Yep.
that we're talking about, do you think that works in an MSSP context with hundreds or thousands of different customers?
In the context of you're an MSSP and you're trying to do that, or you're an MSSP customer? Yeah. It's hard. I think the way that we've been looking at it is, as a managed organization, you can take the first step, but to do it successfully for an MSSP, you have to build it in such a way that a customer can control it better. Because at the end of the day, so my background's in managed defense. I was doing our, Mandiant's MSSP. At the end of the day, no managed organization is going to know enough about an organization to truly customize it all, right? We can start and give you those first 3 or 4 factors, but for it to truly work across the board, across 4,000 organizations, like you said, got to do it in a way that an organization provides input. The way that we've been looking at it is, how do you glean more and more of those factors from all the data that's being collected as an MSSP? Because obviously, expecting a customer to regularly tailor everything is not always going to happen. But we try and glean as many of those factors as we can. But yeah, it's definitely hard.
I do think there are opportunities where you couldn't do kind of the full customization, like completely tailored to that client, but you could do some level of customization based on like a business vertical, like black energy malware. If you're a utility, you're gonna really, really care about that one. If you're a bank, you probably should still care about that, but you probably won't care about quite as much.
Yep.
So there are things like with industry verticals and things where you maybe start to approach that, but like to holistically, completely solve it, I agree with Bubbles.
Those are the first 3 factors we can use. There's probably 300 factors to do it, right? I think I saw another hand.
There's like 4. You guys have a lot.
You're depressing me. Because you're Mandiant and now you're Google. And, every webinar I'm in, it's always, one of the topics is always, there's this shortage of, Homo sapiens that can do cybersecurity.
Yeah.
And one of the big issues that they have with trying to keep people in cyber is false positives.
Yep.
We're chasing rabbit holes all over the place. So I was expecting to walk in here and get excited about how you're automating more of this stuff, and now I'm depressed. So save me from the suicide hotline. What is Google going to do for you to help to smooth this so that analysts feel like they're doing relevant work and not chasing stuff, even if it's just chasing the questions that have to be answered?
Yeah, I mean, we all will officially be employed by Google next month. Good question. We'll hopefully find out after we onboard. But I mean, the way that I look at it is Google has a few more computers than we do. So hopefully we can, bake in some more complexity in all this and continue running down this using their computers, that advantage. But yeah, none of us have access to anything at Google yet, so we'll find out.
The only thing I'd say is that there is, going to actually the first question that was asked, I think there is more opportunity. The more things, right, that, from a machine learning standpoint at least, you can observe that someone is doing, the better customizations you can make for those people, right? I think that's kind of the point of the MSSP thing, right? If you don't really know what the underlying customer is caring about, then it's hard to make those inferences back. I think with something like, some of the Google ecosystem and kind of things that Mandiant brings to the table, we have that opportunity to kind of have a lot of different views from like the customer perspective to really sink our teeth into like, yeah, this is a good understanding of what the customer is interested in based on everything we've observed.
I think, in my opinion, or from my perspective, I'm very skeptical of this idea of humans being fully replaced by machines. I think there's always going to be room for humans in the process. I don't know that we'll ever work it out, but I think part of the focus of our presentation here and the way we've been thinking about it is machines can help with decision making. It can help make your tasks faster. So for example, if someone's trying to sort of evaluate a threat intel hit on their own today at a customer site, some of these questions we ask, if an analyst were to actually manually go and research all of that information on a given indicator, that might be 2 hours worth of work for a single indicator hit. With a product or solution like kind of what we're talking through here, maybe they get all of those answers within the span of like 10 minutes and help make that decision faster. So it isn't replacing the human, but it's assisting the human. I actually pitched that we include a picture of Ellen Ripley in this deck in the mechanoloader from the Alien series. I don't know if that dates me at all. I don't feel like that's old, so hopefully you guys know that. But like it's all about enabling people with the machine. Ellen's in the machine, Ripley's in the machine, and it's the machine's not doing it itself. I'm a nerd, so I do that. But anyway, I really think that's like the future for us right now. I mean, maybe the machines take over one day and they have no need for us anymore, and then that's a sci-fi movie. But for the time being, I really think that assistance, robot machine assisted things is the more immediate future from my perspective.
I think I saw a couple more hands. Yeah.
We had a lot of hands. We only have time for probably one more question, and I think her hand was up. But
We'll be right
they are going to be able to stay afterwards for any other additional questions. But we do have a session at 3:15, so just be a little bit mindful.
Stay that long.
That one.
Well, now I feel all kinds of pressure. So you talked about how algorithms can take away some of the bias in the analysts, but you also mentioned how there are still humans who make the machine learning models. I'm sure at least one of you has read Weapons of Mass Destruction by Cathy O'Neil, and therefore, have you ever seen bias coming into the algorithm that's actually negatively impacted any of this sort of detection? Because I can see that going both ways. And how do you help make sure that that bias either gets worked out or is continuously checked when it's in the algorithm and not in the person?
Absolutely, yeah. So, and I'm going to say something that I'm going to let Bubbles say it because I want to make sure you guys get both sides of this coin. So one of the things I think was the coolest thing about this project that we worked on and the iterative feedback loop that we had is that there were things that came up in our model, right? So as an example, there was certain internal knowledge bases that were, we kind of all agreed at the start was like, yeah, that thing is definitely, if that says it's bad, it's definitely bad. And we would go through and we'd be like, well, wait a minute, this is showing us this is not supposed to be as highly weighted. Why is this happening? And we kind of went through and, by and large, our assumption was correct, right? Our gut feeling was correct. But the reality was that there was still data messiness in there, right? There were certain things that a human analyst put on things that were maybe a little bit too broad, maybe it bled over into something else that it wasn't expected to, and then it kind of got pulled into the algorithm. So, but that, from my perspective, that was actually awesome because something that otherwise an analyst would have to have just happened upon by chance during their investigation and fix then, we were able to kind of systemically find and fix it on a much broader scale than a one-off type thing.
Yeah, I think the thing that helps a lot is in that loop that Scott showed before, there are different types of humans in each part of every loop. So we all have biases, but we all have different biases. And we can kind of catch each other. So as one good example, I went to Scott one day and it was like, listen, if an indicator is highly prevalent, it is definitely benign, and if it is very rare, it is definitely malicious. Like, I am beyond confident in that. And he said, okay, cool, let's go do it. And we built it into a model, and he came back and was like, hey, why do we say that Bloomberg.com is malicious now? And it turns out the data from which we were deriving our prevalence stats are biased in a certain direction, and they do not see like common news websites. And it also turns out that when I use prevalence as an analyst, I'm actually doing 4 or 5 other things before I even decide to use prevalence. And Scott was able to spot that, kind of walk me through the data science-y way to think about it, and like we were able to evolve the model and again address that kind of at scale, which is pretty cool. And that happens 3 or 4 times every time we create a new model. Scott and I talk quite a bit. And with that, I think we're at time, but yeah, we'll hang out if anyone have
Yes, thank
any
you,
other
everybody.
questions.
Yeah, thank you, everybody.